Let's graph our solution. Yes. So, follow this whole journey. Okay. But
Why do we need two solutions? Like, why isn't this just a special scenario where we have one?
hang on, one question at a time. I can, your question is easy. The solution just represents the behavior of the spring under different parameters. Why is it? Well, because it's a second order equation, there needs to be two solutions. That's just the simple answer. And so by doing that, we found out that in fact there are two solutions because it will create one. And because if you just wrote your answer as say c a constant times e to the minus 2t and just said, oh, it's the same, then your solution would really be no different than an overdamped system. It would just be this.
Right.
But it's actually a different solution, and it actually behaves differently. And here's what it looks like. We'll use that to lead into the graph. So at zero, if I look at my solution here, this is going to be a light blue solution. If I look at my solution here, when t is 0, this first term is 0. The second term is C2. So my initial condition, my starting value, is at C2 on this problem. So let's put C2, maybe I'll put it here. Overdamped, let me just come back. These are overdamped, these are real, two real roots. And obviously they have to be, both have to be negative so that it's stable. If it's unstable, it just goes up to the sky. C2, the C2 solution, or this next solution, what it actually does is as soon as you pass 0, the t term kicks in. And it kind of, you can think of it as like a fight where the t term tries to keep the whole thing going up as t is increasing, but nothing can outdo it. T to the minus something is like a black hole. Eventually everything is going to go back down. It makes a great story though, doesn't it? Like, T tries to take the lead, it tries, it just can't hang on, and it just comes back down. That's what happens. This is called critically damped. Critically damped. And what we have, these are repeated roots. All right, let's do one more. One more says, wait a minute, we moved up. We started out with two real roots. We moved it up, they were still real. We moved it up again, they were still real. We moved it up until we had a repeated root. What happens if I was to continue my solution upward? What would I have now? Right, I have imaginary roots, and that's what we want to try next. So let's see what happens now if we have imaginary roots. So, back to the complex numbers. Okay, so let's try this. Let's solve we're going to solve the differential equation. Solve y double prime, how about plus 4, hold on, don't write that yet, y prime plus 5. No, don't write that. Hang on, don't look. I have to double check. Okay, now you look. Plus 5y equals 0. Okay, that's your next solution. And here's kind of the beauty of it. Our approach doesn't change. Our approach doesn't change. And so right off the bat, let's just think about what we know. We know this differential equation, d period, this differential equation has a characteristic polynomial of s squared plus 4s plus 5 equals 0. We know that. How would you have gotten there? You're like, no, is that magic? What would you try? Let's just see if you can remember the process. If you didn't know where to do this, and you hadn't already just done 2 in the last hour, what would we have tried? Remember this, the function, its derivative creates its own like term. What would that be? E. Right, it's e to some exponent. So we said e to the st. So I need an e to the st here. I need the first derivative of it here. And I need the second derivative of it here. And we just combined like terms. We said that we don't need to worry about the e to the st term. We want to figure out how all these s terms, this polynomial, gets to 0. And we're left at this step. That one doesn't factor, I don't think. Does it factor? I don't think it does it? So, you know, there's a beauty of this, is it doesn't matter if it doesn't factor, does it? How can you solve it? Yeah, yes, either one. You can complete the square, or you can use the quadratic formula. And just as a little review, we're going to use the quadratic formula. So in other words, what we would say, I know, really, it's that easy. It is. I know, you're thinking all these years that you wanted that, you just held it in the back of your head, wondering what it was for. And it really was for this. It was so that you could take differential equations. Did you know that? That's what it was for. I know, you thought it was for something else, but that was it. So s is minus 4 plus or minus the square root of 4 squared minus 4 times 1 times 5 over 2 times 1. So let's clean that up. That's 16 minus 20. That's going to be a minus 4. So s is equal to minus 4 plus or minus the square root of minus 4 over 2. Let's clean that up again. That's negative 4 plus or minus 2i over 2. Then I can write that one more time as a minus 2 plus or minus 2i. No, 1i, sorry, 1i. Clean that up, 1i. Plus or minus I. All right, let's write it out. So this says we have our solution, again, two solutions. We have y null is equal to C1 e the minus 2 plus I times t plus C2, someone has a coronavirus? No, he's referred that. E to the minus 2 minus I times t. I have a feeling there's a whole bunch of work coming on here. Let's expand it out. Let's see if we can clean that up. Let's see if we can clean this up. What was that? Yeah, no, we're not. That would be gonna be a lot of easy. Let's see what we can do. Let's see. Oh, remember this. So just so you can see what's going on. This is C1 e to the minus 2t e to the I t. This is plus some C2 e minus 2 t e to the minus I. Oh, well, let's see. Let's factor out our e's here. So I'm going to go equals e to the minus 2t times, I have a big set of parentheses here. Oh, look at this. This is C1 e to the it. I'll write that. I better write that. I have a few. C1 e it. This is plus C2 e I t. Now, I don't think you remember this because you were in the throes of a test. But we've done that. Right? Yes, thank you. I was waiting for someone to catch that. Okay. Well, let's take a look at that one more time. Let's expand this. This is, I think this is probably my last line here. And then we'll move over to the other board. This is equal to e to the minus 2t in parentheses. This is C1 e, not d, sorry. This is Euler's identity. So I'm going to even note that here. I think a few of you on the test were still struggling with that. Use Euler's identity. Both. Just struggling with Euler's identity. When, where, what. So this is C1 cosine. Omega is just 1, so this is just cosine t plus C1I sine t plus C2 cosine t plus C2 I sine t, big Everyone can see over there? I missed one, yeah, this is, oh yeah, this would be sine of minus t, thank you, and then this should be cosine of,
It's easy.
yeah, correct, minus t. So this is even. This one is odd. Okay, so let's clean that up. So I have e to the minus 2t equals e to the minus 2t times, what do I have? C1 cosine of t plus I sine t plus C2. Okay, remember, when we say that cosine is even, that means that the cosine of minus t is the same as cosine of t. Cosine t. And then, if it's odd, the sine of minus t becomes minus the sine of positive t. So this is going to become a minus C2I sine t. We had to come, yes, Brian?
Got to see one.
I did, huh? Oh, yes, thank you, right there. C1. And then here's what we do. Here's what we do. We write e to the minus 2t, and we combine our. I'm gonna come back and fix this. I'm gonna call it big C. Big C1 cosine of t plus big C2 sine. And let's make a note where big C1 is the same as little c1 plus little c2, and big C2 is C1I minus C2. Okay, let's go. We'll wrap up here today. Yes?
Did you from the side?
No, we put it into the constant,
Oh,
into this big C2 here. Good question. I know it takes a little bit of getting used to. Okay. We've actually graphed this. This was I think the last thing we did before the test a week ago. If I just graphed this, what would that be? It's be a circle. Okay, but now as your point advances around the circle, so let's think about this. Let's see, at 0, when t is 0, that'd be at C1, or that is